Okay, we're going to do some more with circles. It's called arc measure and length. We'll talk about what the difference is between those two things. First of all, we need a circle. Here's a circle. Let's move this up a little bit. So it's section 8.3. This is a new marking period. So it's the last marking period. So let's finish strong here. Let's not quit. So here we go. Let's put a center in here. So put a little dot where the center is. Let's draw a diameter. Okay, so the diameter, we'll draw it like that. And let's draw another angle in here. Let's not make a right angle. Let's make it, I'm just eyeballing it. We'll say it's 60 degrees, okay? And let's name some of these points. So we're gonna define a couple things. We're gonna show you another way to. I forget easy words so much anymore. Getting old stinks. What am I just trying to think of? Just the notation. That's the word I'm trying to think of. Okay, we're gonna learn a different notation for something here in a second. But let's label this, and then we'll talk about that kind of thing. All right. All right. So let's use this word. Let's talk about the arc measure. That was part of our name of our lesson. Let's talk about the arc measure. What if I asked you to start at W and go all the way around the circle back to W? All right, how many degrees would you have gone? 360 degrees. All right, everybody good with that? So that's the measure of this, not the distance. We're going to talk about that in a little bit. Okay, but that's the angle measure or the arc measure of that circle. What if I just went from W to Y? Now, how'd you get 180? Just because you know it's 180? It's half of 360. That's right. So one full circle is 360. And we've kind of talked about this when we did the area. Do you remember we did that pi r squared? We put like 60 over 360 and all that. We're going to do basically the same kind of thing here. All right, so it shouldn't be real new to you. So around a whole circle is 360, and then half of a circle, what do? You go 360 divided by, you could go 2 or, let's see, what am I trying to do? I'm going the wrong way. I'm going 180, listen, divided by what? 360. So that would be half of the circle. Would you agree? So half of the circle would be 180 divided by 360 because the zeros cancel. 18 goes into once, 18 goes into 36 twice. So that would be half of a circle, okay? What about a quarter of the circle?
That would be 90.
Yeah, that would be 90. So 90 over 360. Now watch. Let's do this one since we have this 60 right there. What would this be? This would be 60 what? Over 360 degrees. Okay, so what we're doing is this. What we're doing is we are going, actually, I don't even know if what I'm doing has anything to do with what this is. But anyway, that's good enough. Okay, so 60 would be 1/6 of the circle. Would you agree with that? Okay, so you get the idea. Let me show you this. When we talk about an arc, we're talking about the degree measure, all right? So arc measure is measured in degrees. Kind of all over the place this morning, but we'll get going here in a second. So we measure it in degrees. So all the way around the circle would be 360 degrees. If I go from W to Y, what if I go from W to Y this way, or I go from W to Y this way? Same exact thing, isn't it? Doesn't really matter which direction you go. Still 180 degrees. What if I drew? I'm not going to, but what if I drew like a little tiny circle and I went from one end of the diameter to the other? Is that less because it's a smaller circle? No, it's still the same measure of degrees. Okay? Yeah. Be nice if you went before class started. It really would be. So anyway, you go from W to Y, that's 180 degrees. What if I go from W to X? What would we call that then? What do you think?
The arc measure.
Because look, if I started here and went all the way around the circle, how many degrees is that angle right there? 360 degrees. So what if I started here and went all the way around the circle?
60.
So the arc is 360 degrees, isn't it? So tell me something about this angle in the middle and the arc that it cuts off. This is that we're actually getting a little ahead of ourselves, but that's okay. I'm going to do this anyway. So what if I did this? What if I went like from here to here? How many degrees is that line? That's 180. So how many degrees is it from W to Y, that arc?
Okay.
It's 180. Agreed? Okay, now, what if I went from here to here and I said that angle, okay, that angle was 60 degrees, then what would this arc right here be? This would be 60 degrees as well, okay? So we call this a central angle. And again, I'm getting ahead of myself a little bit, but I'm fine with that. This central angle is equal to what we call as the intercepted arc. What does that mean? This makes an angle, and it goes all the way till it hits the circle here, and it goes all the way till it hits the circle here. So it intersects the circle. Would you agree? But we call this the intercepted. Let's write that word down. Like intercept, like interception, right? In football. So we call it the intercepted arc. Right? So watch. If I start here, this is only true about a central angle. We're going to talk about other angles in a circle some other time, not today. But when we have a central angle, if it cuts off this arc at W and X, then this arc right here is also 60 degrees. And again, we measure an arc with degrees. This doesn't mean how long it is. Okay, it means the angle measure, or I shouldn't say angle measure. It's the what? It's the arc measure. Okay, so the measure of this arc, when we say the measure of the arc or the arc measure, we're finding how many degrees. Okay, how many degrees out of what? 360, right? So it's 60 degrees from here to here. Everybody with me? It's 180 degrees from W all the way to Y. It's 360 degrees from W all the way back to W again. Everybody with me on that? All right, that's not so hard, is it? Now, we actually have a way to notate, to show an arc measure, and this is what we do. Actually, let's talk about this first before we do something else. We have basically three types of arcs that we're going to talk about here. The first one is called a minor arc. So this is very important. We're going to talk about this quite a bit. So we have a minor arc, which is less than 180 degrees. So if you have an arc that's less than 180 degrees, we call that a minor arc. And there's a certain way to notate, to show a minor arc, right? So it's important that you understand what a minor arc is. And what do you think? If you have a minor arc that's less than 90, what do you think might be greater than, or I'm sorry, 180, not 90. What if it's less than 90? What's the other word?
Major arc.
Yeah, it would be called a major arc. So a major arc would be more than 180 degrees. Okay? And again, we have a certain way to notate that, to show it. Now we have something else. We have less than 180. We got more than 180. What are we missing? Equal to 180. Okay, so what if it's equal? It's an arc, okay, that's equal to 180. So for instance, from W all the way to Y would be 180 degrees. Agreed? So we call that, it's not a full circle, it's a semicircle. That's right. Some people say semicircle, but if you say it fast, we usually say semicircle. All right? Oh, forgot the L. All right? Yeah, full circle would be 360. But these are all arcs. Even the semicircle is an arc. All right? It's a portion, it's a part of the circle. Everybody got that? It's a part of the circle. So now, let's show you how to, I guess notate's the best word for this, a minor arc. I need to keep this. Yeah, I'll just do it up here. We'll do this in a different color now. I'm tired of just the black and white. All right, so let's do this minor arc. Do you see a minor arc in here in this picture?
Yeah.
Which one is it?
WVX.
Well, that would be an angle. Okay, when we measure an arc, now I haven't taught you this, so I really don't expect you to say this. But remember I said if you go from W all the way to Y, and if you go from W to X, remember that? Okay, so that would be a minor arc. From W to X would be a minor arc. So let me just... That's good enough. A little wiggly, but you get the idea. All right, so that yellow right there is the minor arc. Again, we measure an arc in degrees. All right, so this would be 60 degrees. But how do we write the arc? Well, I'm glad you asked. We write WX, but then we write, here it is, this is brand new, we write a little symbol that looks like that. That symbol, okay, that notation means it's a minor, well, it means it's an arc. Okay, the little arcy thing right there, okay, that thing represents an arc. It's not an arch, it's an arc, A-R-C. A-R-C, Academic Resource Center. Arc, all right? Now, what's very important is this, that a minor arc, you just use 2 letters. Everybody got that? You just use 2 letters, I'll write it down, 2 letters for a minor arc, all right? So minor, I'll just write minor. Use 2 letters and it looks like that. So guess what you use for a major arc? That's right, you do. So, remember, let's put something else in here. Let's put a Z right there, okay? Now, what if I talked about this? Try a different color. What if I went from W to Z? I could get there 2 different ways, couldn't I? From W to Z, I could just go, whoops, killed that. Let's try this again. I could go from there to there, agreed? Now, is that less than or greater than 180 degrees? It's less than 180, because look, from 180 is from W to Y. So 180 would be from W to Y. This is obviously less than 180. It's less than a half a circle. Do you agree? It's less than half a circle. So if I wanted to, this pink arc right there, if I wanted to name the arc, what would I name it? Arc what? WZ. Just WZ. All right? You wouldn't use 3 letters. You just use 2. Or, I didn't say this, but you could probably figure it out. Or you don't have to start at W and go to Z. You could call it what? ZW. Right? You could call it, if I just said Z, you would have no idea that it would even go to here, right? So you can't just call it Z. So if I went from Z to W and W to Z, it's the same exact arc, all right? So I could call it arc WZ, or I could call it arc ZW. But what if let's do it like this. What if I started at W? I didn't even need the Z there. I was thinking going the other way, but let's try to go to there. What if I did that? Now that's a little different. I went from W and I went all the way to X. Can I just call this WX? Can I just call it arc WX?
No.
Why not?
Because
that's a minor one.
That's right. WX would just be a minor arc. What's this pink one right here? It's a major arc. Why is it a major arc? Because it goes more than 180. It goes more than halfway around the circle. Okay. So I can't just say WX, because if I was trying to label that pink arc right there, everybody listening? If I was just to label the pink arc, if I just said WX, I don't know if I'm talking about just going from here to here, or if I'm talking about going from here all the way around. So what's the way to make sure that when you write it down, you know if you're talking about the major arc or that minor arc right there? You would start at W, because it starts at W. Where does it end?
X.
At X, but I can't just say arc WX. I got to have another point. And you only need one. This actually has 2 points in between. It's got a Z and it's got a Y. And it doesn't matter which point you use. As long as you pick where it starts, some point in between, and where it ends, that's how you show a major arc. So I could call it WZX. Now you still put the arc symbol over top of it. Okay, or I could call it what? WYX, arc WYX. Okay, or you could go backwards, right? You could say it's arc XYW, or you could say it's arc XZW. And I think that's all the options for that. I don't think you could name it anything else. You with me on this? Okay, this is just how to name the arc, how to locate it, because if they say arc WZX, how do you know which arc they're talking about? Well, you start at W, you go through Z, right? And you end up where? At X. Does that make sense? So this is a starting and an end point, and again, it doesn't matter which one is the starting or the end. Okay, you could have switched the W and the X around. It doesn't make any difference. All right, you could not put the Z in front, right? You couldn't put the Z in front because that wouldn't represent that pink arc right there. Okay, what do you think? What if I talked about the semicircle? What's the semicircle here?
Equal to 180.
Starts at it's equal to 180, so it starts at W, ends at Y.
Or it starts at Y.
So I could call it what?
WY.
Could I just call it WY?
Or YW.
No. Yes is not the correct answer.
YW.
Because look, even though the measure of the two arcs are exactly the same, the arcs themselves are different. So if I started at W and went to Y this way, that's a completely different arc. Now, it's got the same degree measure, right? It's got the same degree measure, but it's a different arc than if I would have started here. Anyway, close enough. Good thing I'm not a surgeon because I'd be cutting all kinds of places I shouldn't be. So anyway, what if I started at W and all the way? Do you see the blue one and the green one? They're two completely different arcs. They're both equal to 180 degrees, right? Because it's a semicircle, but they're two different arcs. So let's do the blue one. So what would the blue one be? Starts at W. Where does it go through? It goes through Z, and it ends where? At Y. So the blue one would be arc WZY. What about the green one?
WXY.
So starts at W, and it ends at Y, but where does it go through? I kind of wrote over it, but that's an X, so that would be that.
The semicircle is 3 letters too.
Yes, semicircle is 3 letters because I wouldn't know if I just said WY. I wouldn't know if I'm talking about the blue arc, and I wouldn't know if I'm talking about the green arc. Now, again, they're both equal to the same measure, right? They're both 180 degrees, but they're two different arcs, right? They go in two completely different directions. You see it? So with a semicircle, you use 3 points. With a major arc, you use 3. With a minor arc, you only use 2. All right. What if I asked you, remember that pink one? Let's get rid of the blue one. Let's get rid of the green one. That pink one right there. What if I ask you what the measure of? Now, remember in the book, which it's this right here. Remember they put a little M in front of it when they do an angle? Remember that? And I said, I think it kind of gets in the way sometimes, right? Now, some geometry teachers would hate me for that because they'd always put the M there. That means the measure of the angle. If you didn't put the measure there, then you don't know what you're talking about, blah, blah, blah. Whatever. All right, so I have not made you put that little M there. And I'm still not going to make you put that little M there. But what it means is the what? The measure of the angle. Or in this case, it's not an angle, it's a what?
The measure of the arc.
The measure of the arc, okay? So what if I asked you the measure of that pink arc right there?
Probably 120.
Probably?
Or it is. Because
Is it?
this is 60. Oh, no, it's. I was thinking 180. It's
That's right. You're taking away from 180. What should you be taking it away from?
360.
Right. It's a circle. Right. It's a whole circle. It's not just a straight line this time. Okay. It's a whole entire circle. Okay. So that pink one right there, you know the yellow is 60. So what's left over? 300. And how'd you do the math? You went 360 minus what? 60, which is 300 degrees. So I'm going to put the little M right now just to make sure you understand. But the measure of arc, what is it? W, let's call it YX. Is that right? Is equal to what? 300 degrees. And that's the kind of stuff they're going to ask you. All right? They're going to give you some arcs, and you're going to have to find some other arcs. You might have to add a couple together, right, to find another arc. Or you might have to subtract it from something to find a missing arc. All right? And I think you guys kind of have that down. Now we've been doing that kind of stuff all year. But now we're taking it away from 360. That's the difference on this. You've been doing that with angles almost all year, but now we're taking it away from 360. We good with that?
Yes, sir.
All right. Let's do another example that's very similar to that.
What example is it?
This is 1. And let me put another. Let's get rid of it. Let's do this. Let's put a dot where the center is, right there. And now, I'm going to draw a diameter. About like that. And then, that's going to be 60 degrees as well. But this one's going to be a little different. We'll say that one. So that's 60 degrees. This arc right here is 45 degrees. Let's put some letters in here. We kind of use the same letters as we did on that last thing, but just doing what the book does. All right, there we go. So here's the deal. The first question, I'll put A. This is example 1. Example 1. No, you don't really see, you don't see that A, do you? I got to remember that this screen doesn't show everything. There we go. There's A. All right. So let's see. It says find the measure of these various things that they're going to ask you. ZWY. And this is an arc. And this is what they're asking. They're asking for the measure of ZWY. So here's your picture. This could be a homework problem or a quiz or a test or something like that. So what do? Here's Z, here's W, and here's Y. So what arc are we finding? We're finding this big major arc. Plus it's got 3 letters, right? So I'm not just going from Z to Y. I'm going from Z. I'm not going to draw it, make it big and fat like I did the other ones. But I'm going to go all the way around to here like this. Should be pretty easy. We pretty much did the same thing, but we got a different number this time. So what would that arc be from Z to W to Y? How do you find it?
360 minus 45.
That's it. 360, okay, minus 45. Because remember, you're finding everything except this little arc right here, aren't you? If you go from Z and you go through W and you go all the way to Y right there, that's everything except for this. So everything is 360 except for the 45, which means you take the 45 away from it. Right? And what's that, 315?
Yep.
Yes.
All right.
And that's right.
So there's 1.
That's
That was pretty easy.
That'll be number 1 on the quiz.
It might be. I don't know. I haven't made the quiz up yet, so I have no idea.
It's not to the end of the week.
All right, here's another one. Let's take a look at this one. Let's find the measure of arc YXW. So what do? We start at Y, we go through X right here, and then we go all the way to W.
It's a semicircle.
360 minus 180.
That's right. It's a diameter, isn't it? From Y to W is just a straight line that goes through the center, so that's a diameter. So we don't have to do any math at all, do we? You don't even have to go 360 minus anything. You can just look at it and say, oh, that's a semicircle, so it's what? 180 degrees. That was even easier than the first one. Right? Maybe they get easier. Well, I don't know if it could get easier than that, but let's see. Arc ZW. Arc ZW. Now, what kind of arc is this then? This is a minor arc, okay? So it's going to be less than 180 degrees. So ZW, where's Z? Right there. Where's W? Right there. What is it from here to here?
180 minus 45.
Okay? So watch. If you went from Y to W, that's 180, right? But, again, how much is this little bit right there then? If that's 45, then this is what? 45. Okay? And what are we trying to do, though? We're trying to find just that part right there. Agreed? So it's 180 minus 45. Let's do the math. Show your work. Even if you can do this in your head or in your calculator, I want to see this on a homework. Some of you guys have noticed that I have been taking lots of points off for not showing your work, okay? And I'm going to continue to do so. I saw somebody saying, look, I got a 1. And you're laughing. That's funny, okay? I'll tell you what, it won't be long before you're going to see a 0 on it if you're not going to show your work, right? Anybody can just sit there and write the answers down when I give them to you at the beginning of class and turn it in, all right? But that's not the way you should operate. And still, 2 or 3 people are still doing that. When I was grading that homework that I passed back to you, there's like 2 or 3 of you. It's all you did was just write down the answers that I wrote up on the board. All right. So, Anthony, question.
So would y be 120
YX?
Yeah.
Yeah, but they,
Yes, it would be. Yep, because that's 60, and that would be 120. That's right.
Wait, oh,
And then,
never mind.
right, because it semicircles here.
I don't
Yeah.
know what they got.
All right, let's see what they ask for, though. They ask for ZX. Okay, so where's Z? Right here. Where is X? It's right there. So, yeah, it's not a major arc,
It's a binary.
because if I go to Z to X this way, that would be a major arc.
Oh, we're going
'Cause
that
the-
way.
Right, we're going from Z to X. Remember, it's a minor arc, so you have to go the shortest distance from Z to X around the circle.
So it's only 165.
Right? So it's from here to here, exactly. So that would be 45. This is 120. Or you could look at it as the arcs, right? This is 45. What would this arc right here be? That would be 120 because that angle is 120. Okay? So either way you do it, you could look at it inside of here, the angles, and then figure out what the arc is, or you could just write down what the arcs are, just add those up. I kind of like to do it by the angles, don't you? Right? I got a 45 and a 120. I add those up. I'll show the work. 45 plus 120, and that is 165. All right, so that's the kind of stuff that they're going to ask you to do. All right. I tell you what, there's no way I'm going to be able to finish this lesson. This is actually a good stopping point. So what was the title of the lesson? It was arc measure and what? Arc length. Let's just do a sneak preview, okay? Here's a sneak preview of what we're going to finish up tomorrow. So this kind of blows our lesson plan things out of the water a little bit, right? Did I have doing 8-4 tomorrow?
No, we have.
No.
What did I say for
No,
tomorrow?
we did.
Oh yeah, we did.
Look on your thing. What does it
We
say?
do.
It says
Okay.
8-4 inscribed and
Okay.
Yes.
So we're going to be off a day. I'm not sure. I think we could probably still have our quiz on Friday, but we're off a little bit because I'm gonna split this up into A and B. All right. So just because I thought that I might be able to finish this lesson today, but obviously we're not going to. What if I asked you to do this? The arc or the whole entire circle. What if I asked you to find the length of all the way around the circle? This is something that we've talked about before. That would be the circumference. Very good. Okay, so if I talk about the length, so what would this thing right here be? This would be the radius. Let's say it's, I don't know, 5. Okay? Everybody with me? So let's say the radius is 5, and I asked you to find, we'll call that W, we'll call this point X, we'll call this Y. Okay? What if I asked you to find W, X, Y, but I'm going to find the length of, I didn't have enough room there, the length of arc WXY. Now that's different, isn't it? The length. So it's like this. Picture you have a circle. And when I used to teach this full time, I had one in my desk, and I don't have one now, but I had a cardboard circle, and I always had string, right? So I take the string, I'd wrap it around the cardboard circle, okay? And then I would measure the radius of the circle. That was easy to do, right? You just take from the center anywhere outside the circle, and I'd measure that. And then we figured out what the circumference of the circle should be, all right? And we have a formula for that, right? What is the formula for the circumference of the circle? It's 2 pi r. Okay? And then, so that's what you're doing. The circumference, if I take that string and I wrapped it around that circle, so if I put one end of the string here and I wrapped it around here, and then I took it, right, cut it or whatever, and then I stretched it out, took a ruler and measured it, that's the circumference of the circle. So that's the distance around the circle. Everybody hear me? It's the distance around the circle. So that's what I'm trying to find. That's the length of that arc. In fact, this is a huge arc. It's the whole entire circle. It's such a big arc. Okay? So if I wanted to find it, it would be 2 pi r. What if I just wanted to go from, and let's say this was, I don't know, that looks about 100 degrees right there. What if I wanted to find the length, we'll kind of teaching this now, aren't I? But we're going to get into a little bit more detail tomorrow. So what if I wanted to find the length of arc WY?
So it's line 1, 2, 2. So
No.
it'll be 200.
I'm not finding the measure of the arc. Okay, the measure of the arc would be 100 degrees. I'm finding the what? The length of it. So if I took a string, listen, if I took a string and I started it here and I wrapped it around to here, stretched it out, measured the string, how long would that piece of string be? That's the difference. That's the difference, okay? Now, I'm not finding the length of the whole entire circle. This would be the whole entire circle, 2 pi r, correct? How much of the circle am I finding?
WY.
100 degrees out of what?
360.
360,
Theta.
okay? Times what?
Pi r.
It's 2 pi r. That's right. 2
I forgot the 2.
pi, and then what's our r in this situation?
5.
It's 5.
I need that.
Everybody see that? I don't know what this is, but let's that's 10, right? So what do we have? We have 100 over 360, and then we have a 10 and a pi. Well, this 10 goes with this, right? And then whatever that is, I would just put it in a calculator, all right? 100, let's do it. You got a minute? So let's see. Yeah, 100 divided by 36 times what?
10.
No, the 10 canceled out. Remember? That 10 canceled out with that 0. Times what? 3.14. Okay, and that's about 8.7. Now, when I said about, right? Why did I say it's about?
Because
That's right. It's approximately. It's approximately. It actually, the 2 actually repeats forever and ever, right? So it actually does, but it doesn't like come to a final answer. But anyway, it's 8.72, whatever this is. Let's say it's in inches. So this would be what?
8.72 inches squared.
Is it squared?
No,
Why not?
because it's not area.
It's not area, right? It's the length of a piece of string. A length of a piece of string is not squared. Agreed? All right. So anyway, that was sneak peek. That's the kind of stuff that we're going to be doing next. What's that?
I don't find the portion with anything.
You mean pi?
There might be some situations we're going to have to.
So do we not
But
the length of WY?
We haven't got there yet. We're not finished this lesson, okay? So we're not completely finished it. What's that?
I still think I did just not find WXY.
Well, this is just one of the questions they could ask. Okay, I just gave you a really simple one. So what did you just find? You found how long that string is from there to there.
Do you want that
Okay.
in pi form or
So it's- I'm fine if you put it in a calculator like this because sometimes they come out nice and even, sometimes they don't. If it comes out like nice and even and it comes out to like 3 pi, which some of these will, then it's fine if you just put 3 pi. But it's also fine if you put it into a calculator and get a decimal. I'm okay with that. All right? If you want to get started on the problems that you can do, you've got the problems and you got the lesson plan thing in front of you. If you want to start on the ones that you can do, just leave out the length of the arcs, okay? Do the arc measure ones, then you won't have so much to do tomorrow, okay?
Are we turning these both in Wednesday?
Yeah, they'll both be due on Wednesday.